Welcome back. This is the fifth and the last example problem in topic 1. And Professor Goldluck is back trying to buy a house. So this time he just needs the house to be big enough. We call that a spacious house. So it's at least 2,500 square feet. And the setting is somewhat different from the previous problems. So here there are n houses, and these n house, each of them will become available on one day. So over n days, every day the new house will become available. And every house will stay on the market for exactly 2 days. So if a house becomes available today, it's also available tomorrow. So Professor Goldluck can decide to wait until tomorrow to buy the house. And so he has a heuristic to decide which house to buy, because in this setting you cannot just wait until the end and then see which one is the best, because by that time the best house may be gone. So Professor Goldluck heuristic is if a house has a PPSF index that's no more than half than the highest PPSF index among all houses he has seen so far. So we assume that this price per square foot cannot vary too much. So if there is a house that has a price per square foot only half of the highest he has seen so far, then he considers that a good deal. So this highest PPSF among all houses, this include the houses that are not spacious. This also include the houses that just become available today. So maybe today you see a very expensive house. This makes the house that available yesterday become very attractive. So you'll go decide, Professor Goldluck may decide to buy that. And once he see a good deal, Professor Goldluck will not let a good deal slip through. So this means that when he see a good house, he doesn't have to buy it on that day. If the house just became available on that day, he can wait because the house is still available tomorrow. And the benefit of waiting is tomorrow he may see another even better deal. He see a house that's also spacious, that has even lower PPSF. And in fact, then he doesn't need to buy the house today. He can sort of try to buy that house, and he doesn't need to buy that at that moment either, because he can afford to wait another day. So only when today's house is not as good as yesterday's, then sort of Professor Goldluck has to buy that one to not let that good deal slip through. So let's look at some examples. So in the first sample example, we have 6 houses. On day 1, this house become available. So this one is definitely spacious, and it has a PPSF of 300. So actually among these test data, 300 is the highest PPSF. So anything that's lower than, less than, or equal to 150 is a good deal. So the house on day 2 has a PPSF of 60. However, it's not spacious, so it only has 2,000 square feet. So we're going to skip on that one. And the house on day 3 has a PPSF of 200, but this is not a good deal. So it's not, it's greater than 150. And on day 4, the house is not spacious. So on day 5, we have a house that's spacious and also have a PPSF of 40. So this is a good house. This is a good deal. He cannot let this house slip through, but he doesn't have to buy it on day 5. He can wait until day 6. On day 6, the house is spacious, but the PPSF is 50. It's higher than the one on day 5. So he'll just buy the house on day 5. So he output the house on day 5, which is marked in green. Let's look at the second example. So again, we have 6 houses. Again, the first one, now the first house is not spacious, but it has a PPS of 300. And this 300, we still use that as the max. So seeing that we know any house that's less than or equal to 150 PPSF will be, and spacious will be a good deal. So day 2, the house is not spacious. Day 3, the house is spacious, but had a PPSF of 180, so this is not low enough. In day 4, the house has a PPSF of 100, So this is spacious and it is low enough. So we cannot let it slip through, but we don't have to buy it on this day. We can see whether we can get an even better deal. So wait until day 5. We see a house with a PPS of 60. So yes, so this is a better deal, but we can further wait. And on day 6, we see a house that's spacious with a PPS of just 50. So Professor Goldluck decided to buy this one. So because this is the last house, he cannot wait further to see whether there's an even better deal. So the next sample example, sample input output. So I suggest you actually go through the list and decide which house Professor Goldluck should buy first. Okay, so day 1, the house had a PPS of 50, and day 2, house of PPS of 140. So this is 140 is the max so far. And day 3, the house is spacious and the house a PPS of 72, which is not low enough for now because 72 is greater than 70. And house on day 4 has a PPS of 100 and not spacious. House on day 5 has a PPSF of 75, which is not low enough right now. And on day 6, we see a house with a PPSF of 150. So at this point, the max of PPSF is 150. So on day 6, the max of PPSF we've seen so far is 150. So that means 75 is a good deal. And the house on day 5 is still available. So Professor Goldluck will buy a house on day 5. So I suggest you to try to code this problem yourself. So this is a hard problem. So in fact, I believe many software engineers will have trouble coding this one. So they may be able to code it in the end, but it will probably take a long time to arrive at a correct code, and the code may be longer than or more complicated, longer and more complicated than necessary. So if you are really beginner, I don't expect you to be able to solve this problem. If you are, then I think you are great. You have great potential for programming. But trying to think through, trying to do it, I think will help you sort of appreciate what we are going to discuss for this problem.